Hello everyone. In this session, we are going to see the first topic of the subject, electromagnetic field theory. So we can generally say it as EMF. So electromagnetic field theory is mainly consists of mathematical calculations and mathematical formulations. So based on our mathematics, we are going to implement the electromagnetic wave propagation. Right? So first topic of our syllabus is vector algebra. So generally what is mean by vector algebra? So it is an essential topic of algebra. So it studies the algebra of vector quantities. As we know, there are two types of physical quantities. One is scalar and the other one is vector. So generally what is mean by scalar? Generally, what is mean by scalar? A scalar is a physical quantity that has only magnitude. Whereas the vector quantity has both the magnitude as well as the direction. Whereas the vector quantity have both magnitude as well as the direction. See here, this is the example of vector quantity, that is A. What is mean by this A? This A represents the magnitude, which can also be said as a quantity or a variable. So, which represents the magnitude. Generally, a variable can be named as scalar. So, scalar variable. We used to say it as scalar variable. So, scalar variable is nothing but a variable which is used to represent the magnitude. Whereas this theta, what does this theta represent? This theta represents the direction. Direction of any physical quantity. Generally, what does the direction mean? How any object or any person is moving in which direction. So, which can be represented in the form of theta. So, you should know how to find the components of a vector. So, generally, a vector should have both the quantities, both the components. What are the two components? One is magnitude and other one is direction. See here, let us consider a vector A. See this diagram. Let us consider the vector A. This A vector is moving in the direction like this. This arrow mark represents the direction, whereas this theta represents the angle at which the A vector is moving. This theta represents the angle at which the A vector is moving. Right? So, from this figure, we can say how the vector is moving in which direction as well as the variable. This variable represents the length or distance traveled by that particular vector. Right? So, generally F is equal to ma. What is the equation? F is equal to ma. What does this equation represents? What is the name of this equation? As you all aware of that equation, F is equal to m into a. F is force, m is mass and a is acceleration, right? So this arrow mark represents the vectors. What does that arrow mark represents? The vector can be represented in the form of arrow mark, okay? So generally in mathematics, a magnitude of a vector is termed as scalar quantity, okay? Then see here, Ax is equal to A cos theta. Ax is equal to A cos theta. Whereas Ay is equal to A sin theta. What does this cos theta and sin theta represents? How can we find out the cos theta and sin theta generally? Generally, what is the formula for cos theta in trigonometry? How can we find cos theta in trigonometry? So, cos theta is equal to, by considering a right triangle, let us assume this is theta. I am assuming a right triangle over here. Let us assume this is theta. Now, tell me, how can we find out the cos theta for this triangle, right triangle? So, let us assume the variables A, B and C. Okay? Okay. Now how can you find cos theta? So cos theta is equal to adjacent side by hypotenuse, right? So this is our hypotenuse. For this theta, this is our adjacent side, right? So AB is our adjacent side, and what is the opposite side of this theta? AC is our opposite side, right? So AC is our opposite side, AB is our adjacent side. Then how can we write the formula for cos theta? So cos theta is equal to, here for this theta, the adjacent side is AB. So I am writing AB divided by the hypotenuse is BC. So AB by BC. This is the formula. This is the formula for cos theta. Whereas in order to find sin theta, how can we find out sin theta? So sin theta is equal to, how can we find out sin theta? Sin theta is equal to, if you are having doubts, please mention it in the comment box. Now we will find sin theta for the same right triangle. Okay. Now we will find the same right triangles sin theta, A, B and C. So generally what is the formula for sin theta? So sin theta is equal to opposite side by hypotenuse. Okay. Opposite side by hypotenuse is our sin theta. Now what is our opposite side over here? See this right triangle where it would be. So AC. See here, this is the opposite side, right? So AC is the opposite side for that sin theta. So I am writing here sin theta is equal to AC divided by BC. Okay. So this is how I have found out the A, so that is cos theta and sin theta. So this is the formula for AX. AX is this axis and AY is this one. Okay. So this is the formula for sin theta and cos theta. So now we can know how to find the vectors for which the magnitude and direction is given. Okay. Okay. Okay, then projection of a vector and vector components. Projection of vector and vector components. When we want a component of a vector along a particular direction, see, I just want to find the component, exact value of a vector when it is moving along a particular direction. It is useful to think it as a projection. So projection is nothing but the length, that is A cos theta. See here, already in a last slide itself I have explained you how can we find out A cos theta and A sin theta. See, A is the length of the vector, where theta is the angle between the vector and the direction along which the component is moving, right? So generally this theta represents the this theta represents the angle between the vector element as well as the direction along which the component is moving. See this expression, A vector is equal to AX I vector plus AY J vector. See here, any vector is represented in 3 dimensions. That can be projection in XY plane. See here we are having 3 axes. What are the 3 axes? X is here and Y is here and this is our Z axis. Here I am going to project a vector in 3 dimensions. What is this 3 dimension? In terms of 3-dimensional axis we are going to represent a vector. Okay. So this vector projection will makes the angle of phi. See here, this angle represents phi. Okay. Now project a vector in Z axis along the direction of earlier projection. Already we have projected in 2-dimensional way. See here, we are having only two directions, right? In our next slide, we are seeing the same projection in three-dimensional manner. There we are having one more axis over here, that is said to be z-axis. See here, here we are having x-axis, y and z, right? So the virginal vector makes an angle theta from the z-axis. So this original vector, A vector, makes an angle theta from the z-axis, and the angle between the x and y axis will be represented as phi. Okay, so these are the projection of a selective. Here we are representing a particular vector in the three-dimensional format, right? So here three dimension in the sense x-axis, y-axis and the z-axis. This is how we are going to project a vector in the three-dimensional format. Okay. Thank you all. Thank you for watching this video. If you are having any doubts, please post it in the comment box. Thank you all.